Alright, hi. So today's topic is properties of real numbers. So our goal for today, first one, we're going to identify and use properties. Our second one, we're going to use counter examples. That's going to be kind of a hard one. It gets a little confusing, but I'll definitely walk you through this one. Alright, we have two main vocabulary words, commutative property. And commutative property basically means that you can add or multiply in any order. So let me give an example. Example would be, if I take 7 plus 3, that's the same as taking 3 plus 7. They both become 10. So it really doesn't matter which way. So that's just a property that you should know about, just the order of how the numbers are going. Alright, the next one is associative property. And associative property means that if you're changing the grouping, it will not change the answer to an add or a multiplication question. So let's just do something easy. So if I take something like 2 times 1 times 3, and I say I'm going to group that first, that's the same thing as saying 2 times 1 times 3, and I'm going to group that. If I take this, because of the grouping, that gives me 2 times 3. If I take this, it's the same grouping. So you're both going to come out to be 6 as well. Now, a way that you could kind of remember this would be commutative. The word commute means to move. So if you notice, the numbers switch places or they move. Okay, kind of like when your parents go and they commute to work. They have to go from one place to the other. Okay, and then they got to come back. So going there and then coming back. So 7 plus 3, 3 plus 7. Associative property. It's like the NBA, National Basketball Association. Okay, so it's a group of players that play against each other. You can also think of it as like an association would be like your group of friends. You're associated to your group of friends, and it's a grouping. So normally it's all about a grouping. Now if you look at it here, the grouping changes. However, your answers stay the same, and it's also in the same order. Notice it's 2 times 3, 2 times 3, 2, 1, 3, 2, 1, 3. Okay. So that's how you can kind of distinguish between both of them. Alright, here we have identifying properties. It's our first concept that we need to get through. So let's look at this. We're going to identify which property this belongs to. So this is 9 plus r is equal to r plus 9. So if you notice, the letter and the number switch places. So according to what we know, when they switch places, that's basically your commutative property. So we're just going to go ahead and just abbreviate, just because I'm a little bit lazy. So we're going to call this commutative property, and since we're adding, commutative property of addition, CPA. Alright, how about the other one? Here I have 4 plus x plus 3y. It's okay if you have variables, so we have 3 terms right here, 4 plus x plus 3y. Notice, same order, but the only thing that changes is your grouping. So since we're talking about grouping, we're talking about the associative property. So again, we're going to go and call this a associative property. Since we're adding, APA. Here we have 7 times the quantity of m times n is equal to the quantity 7 times m times n. Now if you look at it, 7mn, 7mn, the order is the same, but the grouping is different. Since the grouping is different, then we're going to call this the associative property, because we're talking about the grouping that's different. Associative property, if you notice we're multiplying, so we're going to call this APM, associative property of multiplication. Then finally, CAB is the same as BAC. So if you look at it, the letters switched, they switched places, so that's going to be our commutative property. And since we're multiplying, CPM. That wasn't so hard. That's a simple one. So all you really have to do is just identify. Alright, number 2, we're going to find counterexamples. So a counterexample is something that's going to show that this statement is false. So right here, this statement is telling you that no month has fewer than 30 days. But that's entirely wrong, because the month of February has 28 or 29, depending on which year that you're talking about. So you're going to go ahead and give a counterexample, and the counterexample would be, no, February has 28 days. So all you're really doing here is, when you're trying to find a counterexample, is just to find something that makes it false. So let's talk about the commutative property. The commutative property is true for subtraction. And what this basically means is, if we took the commutative property, so let's take something like 7, and since we're talking about subtraction, minus 3, they're telling you that if you were to take the commutative property, which means it's switched, is that true? Well, if you look at it, 7 minus 3 is going to give us 4. 3 minus 7 is going to give us negative 4, which means they are not equal. That is your counterexample. Okay? Maybe it's not that hard. Alright, so now, let's talk about closure. Now, a statement is considered closed if you can't find anything false with it. So, let's take a look at the statement. The days of the week is closed for days that end with a Y. So, the challenge here is to look for something that has, that is a weekday that doesn't end with Y. Well, if you look at it, Sunday, now. Tuesday, now they all end with Y's. So, which means this statement is totally true. Even though it tells you it's closed, that means you can't find anything false with it. Okay? So, how about this one? Natural numbers are closed under subtraction. Well, let's look at that again. So they're telling you natural numbers, and natural numbers are your counting numbers. So what they're telling you is that natural numbers, if you subtract them, they will always be a natural number. So let's try something. So if I take 4 minus 3, that'll give me 1. That's pretty true. Counting number, subtracted counting number gives me a counting number. But what if I took any other counting number? Like, give me something, I just want something to be false. So how about I just reverse that? 3 minus 4, well now, that's a counting number, that's also a counting number, and I'm subtracting them. So 3 minus 4, well, that actually gives me negative 1 under, if you can remember what we did for subtraction rules for integers. This right here is not a natural number, which means we've just found the counterexample. So this is no longer closed. Okay, so once again, natural numbers are closed under subtraction basically means that if you subtract any natural number, it'll always be a natural number. But we found out right here that that is not true. Alright, there's one more that I need to go over. If you have any questions about this one, we can cover it in class as well. And this is something that we've already covered before, which is that this distributive property. So I'm just going to go over the basics of it. So let's go ahead and look right here. So here, again, distributive property, all we're going to do is take this and distribute to every term. Okay? 4 times 2b is going to give us 8b. 4 times 3c, positive 3c, is going to give us 12c. And that's plus. Here's a negative 4 times positive 2. That's going to give us negative 8b. And then a negative 4 times a positive 3c is going to give us a negative 12c. Sometimes you might see this as negative 8b plus negative 12c. And if you look at it, that's actually the same thing. Okay, because you're adding a negative number or you're subtracting 12. Either way on the number line, you're still going to the left. Okay? Here, I have negative 4 times a negative 2, which makes it an AB, because it's positive, 2 negatives. And here, negative 4 times a negative 3c gives me a positive 12c. And don't forget, I'm keeping that plus sign right here. Okay? Alright, and this is just a quick recap of your distributive property that we covered before.